Okay, we're going to be looking at finding the equation of a line when we've been given 2 points specifically. Okay, so first example, we've given the coordinate 1, 2, and another coordinate 5, 10. So these are 2 points. And if we were to graph 2 points, we could easily connect the line, right? So let's make a rough sketch of something like that. Okay. If we were to draw these 2 points, we know that, well, this maybe is 1, this is 2, so here's a coordinate here, here's 1 and 2. And another coordinate is at 5, so maybe 5's over here and 10's way up here. Okay, here's 5, 10. We can essentially draw the line, but we need the equation of it. Okay, so we want to create an equation. And in our equation, we usually work with slope y-intercept. So y equals mx plus d. This thing is not responding well. Okay. And essentially, the important things we have to find are our slope and our y-intercept. With 2 coordinates, we can find slope very easily. Okay. Remember, slope's equal to many things. Rise over the run, change in y over x. One of the things it's equal to is an equation. And one of our equations was y2 subtract y1 divided by x2 minus x1. Okay? And essentially what those are is we need 2 coordinates. So I'm going to call this my coordinate number 1. So this will be my x1, and this will be my y1. And I'm going to call this my coordinate number 2. So this is my x2 and my y2. Okay? Yeah, Char? All right, so since we've laid those out now, we're going to just plug these values into our equation. So our y2 was 10, and our y1 was the value of 2. So our equation reads 10 subtract 2. Okay. On the bottom part of this, our x2 was 5, and our x1 was 1. So we have 5 subtract 1. And we're going to solve both the top and bottom part of this fraction. What's 10 subtract 2? 8. Okay, so 8. And what's 5 subtract 1? 4. And what is 8 divided by 4? 2, exactly. So we now have our slope. Okay? Our slope, or our m, is equal to 2. So when we go to plug this into our equation, we have y is equal to, we can replace m with the value of 2, x. The only problem is we still don't know our b. Okay. So that's okay, because remember we talked about yesterday when we know the slope and have a coordinate, and in fact we have 2 coordinates, what we do is we plug the slope in, and then we plug the coordinates in for x and y, and it helps us solve b. Okay, so yesterday we've gone from this point here. So I can choose either of the points. And the first one's 1, 2, and the other one's 5, 10. I'll show you by doing both of them. Okay, so the first coordinate we're going to plug in is 1, 2. And the second coordinate we'll plug in is 5, 10. Sorry, this is responding slow. So we're going to plug them both into this equation. This is an x, and this is our y. So we're going to replace our x and our y with those values. Okay. So our y, in this case, is 2. So we're going to replace y with the value of 2 is equal to, we still have our slope of 2, and our x value is 1 plus b, and we're going to isolate for b. On the right under here, I'm going to do the same thing. This is my x, and this is my y. So I replace y, so 10 is equal to 2. And our x coordinate was 5, so I replace our x with 5. Does this step make sense, what I'm doing? I'm doing the exact same equation with 2 different coordinates. Okay, so these are the same thing. The only difference is I plugged in these coordinates for this equation, and I plugged in these coordinates for this equation. We want to see if we'll get the same y-intercept. And we should, since both of them end up on the same line. So we're testing out this theory. What's 2 times 1? Yeah. So we get 2 plus b. And in the other case, what's 2 times 5? 10. How do we isolate for b? Yeah, move the 10 over in this case and the 2 over in this case, so we have 2 subtract 2 is equal to b. And in this case, we have 10 subtract 10 is equal to b. What's b going to be equal to? 0, that's it. So b equals 0. So the y-intercept, no matter which one we plugged in, we got the exact same y-intercept. So when we go to plug it in the equation, y is equal to, remember the slope was a value of 2, x, and we replace our b with the value of 0. Do I have to write the 0 in? No, this is really just equal y is equal to 2x. So before I do anything else, I want you guys to try this one here with those two coordinates. Try to find an equation. Okay, so we have another example here. We're going to try this one out. Remember, we have to create y is equal to mx plus b. Okay? The first thing we want to do is find the slope, and our slope is equal to that formula we had of y2 y2 subtract y1, all divided by x2 subtract x. Sorry, the 2's kind of look like exact right. Okay? I can call either of these coordinate 1. So in the last one I called coordinate 1, the one on the left. I'm going to call this guy coordinate 1. It really doesn't matter. So which would make him x1 and y1. And I'm going to call this one coordinate 2. Kind of worked. So that makes that y. Nope, that makes that x2. And this is y2. Okay? So we're going to plug these values in. My y2 is negative 3, and my y1 is negative 8. So my question now reads m is equal to y2, which was negative 3, subtract y1, which was negative 8. So I'm going to put it in brackets here. Okay. And we're going to talk about that type of subtraction in a second. One second. And then on the bottom, my x2 was negative 2, so I have negative 2. Subtract my x1, which was 6. So just the number 6. Okay? So we have to remember our integer rules here. Negative 3 subtract negative 8, that's like adding. Okay? So because that's like adding, negative 3 plus 8 becomes positive 5. If you're unsure, you can type it into your calculator, but you got to look over your integer rules. Negative 2 subtract 6 is negative 8. So, since that's our slope, we have y is equal to, and our slope in this case is negative 5 over 8 times x plus b. Now remember, the next goal is to solve for our y-intercept. So I choose one of the coordinates. I'm going to choose coordinate 1. I'm going to plug this one in. I only need to choose one because we know both will give us the same answer. So I plug 6 in for the x, and I plug negative 8 in for the y. Okay. So we get negative 8 is equal to negative 5 over 8 times value of 6. So we have to remember our fraction rules for this. Okay? When I multiply fractions, remember I can make 6 a fraction. And when we multiply fractions, top by the top, bottom by the bottom. So I'm going to put the negative on top, or think of it as a negative times a positive value. We know our answer will be negative. 5 times 6 is 30. Good. And what's 8 times 1? Great. Now the goal is to get b by itself, so I need to move this negative 30 over 8 to the other side. So it becomes negative 8 plus 30 over 8. Now the problem is, can I just add these? Why not? Because I don't have a common denominator. Right now the denominator is 1. So I need to multiply this fraction by 8, both the top and the bottom. In order to, so, negative 8 times 8 is negative 64 over 8 plus 30 over 8. Okay. That's right, it's going to be negative 34 over 8 is equal to b. So, our equation, remember we have to write in y equals mx plus c. Y is equal to, our m was negative 5 over 8. Times x. And our b was negative 34 over 8. I know that looks like a multiplication, but that's a variable of x. Okay? So let's do the dual page. So same process, done twice.